Hi Math 2, this is Factoring Quadratics Review, and in this worksheet we're reviewing how to factor, and that's a topic that you learned last year in Algebra 1 in Unit 7. So last year this would be Unit 7. It's the last workbook we had from Math 1, and this is the first half of the unit. So the first type of factoring that we did was factoring out a greatest common factor. So we would look at our terms and find out what they had in common, and we would factor that out. So for example, looking at the first example, it says 14y squared plus 21y. The 14 and the 21 both have a 7 in common. So I'm going to be factoring a 7 out. And the y squared and the y, the variable parts, this is y to the first, if there's nothing there, then they both have a y to the first in common. So they both have a y that can be factored out. And so when I factor it out, it's really like division. I'm going to think about 14y squared divided by 7y in my head. And when I do that, I get 2y left over. So when I factor my 7y out, I get 2y. And when I factor my 7y out of 21y, I get 3. If you're wondering if you've done this correctly, all you need to do is distribute your 7y back into your parentheses. And when you do that, you should get 14y squared plus 21y again. So let's take a look at doing that one more time. So this is a trinomial because it has 3 terms. This was a binomial because it has 2 terms. And here I look at my coefficients and they all have a 2 in common. So in this particular polynomial, I can factor out a 2. They do not have any variables in common because they don't all 3 have an x. So I'm just going to factor a 2 out of each one. 2x squared divided by 2 would leave me with x squared. 10x divided by 2 would leave me with 5x. And finally, 6 divided by 2 would leave me with 3. And that would be my polynomial in factored form. So the next type of factoring we did was when our trinomial had a coefficient of 1. So for example, factoring quadratics with a equals 1. Remember, your quadratic expression is ax squared plus bx plus c. So in all the problems here, my a is really a 1. So let's take a look at the first one. So for example, this is my a is 1. So when I want to factor this, I would like to factor it into 2 binomials that when I multiply them together, I would get x squared minus x minus 20 back. Well, one of the methods to do that is to use what's called the diamond or the x method. So in the diamond method, the number that we write at the top of the diamond will be a times c, and the number we write at the bottom of the diamond will be our b. So looking over here, a is my first coefficient and my last number is c. So in this problem, my first coefficient is 1 and my last number is negative 20. So I'm going to write a negative 20 at the top. And then my b is my middle term. So b then is a negative 1 because there's nothing there, so I know it's a negative 1. At this point, what I want is 2 numbers to put on the side. These 2 numbers have to multiply to negative 20, hence the little dot at the top of my x. And they have to add to negative 1, hence the little plus sign at the bottom of my x. So I'm trying to think of the factors of 20. So in my head, I'm thinking about the factors of 20. 1 times 20, 2 times 10, 3 doesn't go into 20, 4 times 5. I'm going to stop there because 4 and 5 could also give me a 1. So I think I'm going to try using these 2 as my side numbers. But now I need to think about my signs. When I multiply them, I want to get a negative answer. That means one of them has to be negative. When I add them, I'd like to get a -1. That tells me that the larger number has to be my negative. And so in my parentheses, I write the 4 and the 5. And it doesn't matter what order I write them in. I could have wrote the x minus 5 first and the x plus 4 second. It makes no difference. So let's take a look at a problem that has a GCF. You might be looking at number 2 and you're thinking, oh, that doesn't have an A, that's 1. Actually, it does. We should always look for a GCF first. It makes my math simpler to pull the GCF out at the beginning. So I'm going to factor out a 2 from every single term in here, all 3 terms. 2x squared divided by 2 is x squared. 14x divided by 2 is 7x. And 12 divided by 2 is 6. So now that I've done this, I'm going to not worry about the 2 on the outside anymore. It's just going to stay on the outside as a coefficient. But I'd like to factor my trinomial into 2 binomials that when I multiply them, I get x squared plus 7x plus 6 again. So let's set up my diamond. At the top of my diamond, I put my A times C, and at the bottom of my diamond, I put my B. In this case, my A is 1. The coefficient in front of x is my yellow 1 that I wrote in right there. The coefficient is not a 2. Remember, I factored it out. So, sorry, this is a yellow 1 right there. So A is 1 and C is 6. 1 times 6 would be 6 on top. And then my B is 7. Notice I'm using the numbers that are on the inside of my parentheses. So now I'm trying to think of the factors of 6. The factors of 6 are numbers such 1 times 6, 2 times 3. And so I'm looking at those and I want the combination that will help me get 7. Well, 1 plus 6 could help me get 7. So let me put those in my side and double check my math. 1 times 6 is 6 and 1 plus 6 would be the 7. So it looks like those two numbers work. So I'm going to write them in my parentheses, and it doesn't matter which one I use first. I'll use the 1 first. And my answer would be 2 times x plus 1 times x plus 6. If you're worried you did it wrong, I would box or FOIL the x plus 1, x plus 6, and then multiply a 2 times all 3 terms, and you'll have your original problem back. Try numbers 3, 4, 5, and 6. Check your answers in the locker and bring your questions to Zoom, our next Zoom. The next problems may not be review for some of you. Some of you may not have done factor by grouping last year. Factor by grouping is a really useful skill for Math 3. You're going to have to be able to use it next year, and we're going to use it on the back side of the notes when we do trinomials that have an A that's not 1. So factor by grouping generally has 4 terms. So if you look at these 4 problems, you'll notice they all have 4 terms. To do factor by grouping, step 1, we're going to underline the first 2. And then we're going to underline the last 2 terms. So let's go to number 8 and work on it for a moment. We'll underline the first 2, and then separately I'm going to underline the last 2. Step 2 is we're going to factor out a GCF from each pair. So let's take a look at number 8, s squared and s. I'm trying to think about what they have in common. Well, they both have an s to the first. They both have an s. So I'm going to factor out an s. S squared divided by s would just leave me with s to the first. And s divided by s would leave me with 1. So when I factor out an s from s squared minus s, I get s minus 1. So now I'm looking at 4s minus 4. They both have a 4 in common. 4s divided by 4 would leave me with an s, and 4 divided by 4 would leave me with 1 and negative 1 because it was a negative 4. When you get to step 2, your parentheses should match. So if your parentheses don't match, then you've got a mistake. So now notice that I have an s minus 1 and an s minus 1. I should. If my parentheses don't match, I need to go back and see what I did wrong. So now for step 3, we're going to factor the parentheses from both terms. So I still only have 2 terms. My first term is this entire front half in front of the plus sign, and my second term is this entire back half after the plus sign. So I want to take the s plus 1 out, or I'm sorry, the s minus 1 out, because they both have an s minus 1. When I do that, I open new parentheses, and I look at my first half. When I take that s minus 1 away, when I cancel it out, I would have an s left over, this single s in front. And in the second half, in the back half of my expression, when I divide that by my s minus 1, when it cancels out, when it goes away, then I would only have my 4 remaining. And this would be my expression fully factored. So let's look at number 10. Number 10, I'm going to do my steps. So I'm going to underline the first 2, and I'm going to underline the last one. Step 2, I'm going to factor out a GCF from each pair. So I notice that I have an 8 and a 64. They both have an 8 in common. Now be careful with your variable. You have an r cubed and an r squared. They both have an r squared in common because I want to take out more than just an r because they both have an r squared at the minimum. So now 8r cubed divided by 8r squared would just leave me with an r. You can almost picture your work if you need to write it out to the side. When I do this, when I factor out my 8r squared, the 8's cancel. And if you remember your exponent rules, r cubed divided by r squared, we subtract our exponents and we get that r that I wrote inside the parentheses. Minus, and then negative 64 divided by 8 is 8, and r squared divided by r squared is 1. So I would get r minus 8 when I factor out my 8r squared. So now let's look at the r minus 8. A lot of times this seems confusing because they don't have any factors in common. They don't both have an r, they don't both have an 8, there's nothing I can factor out. So we factor out a 1 and we just write it again. You have to do this step. You have to factor out the 1 because now I'm ready for step 3. I'm going to factor out the r minus 8 in both of them. So I have my r minus 8 that's in both of my terms. When I factor the r minus 8 out of the front part, I have 8r squared left. When I factor it out of the back part, I have my plus 1. That's why it's so important to factor out the 1 because I write it in my second parentheses and I need to be able to see it so I remember to write it. And this is my answer. This is that 4-term polynomial fully factored out. If you wanted to double check your answer, you could create a box and you could write, for example, r minus 8 across the top. You could write your 8r squared plus 1 down the side, and then you'll find when you do your math, you get the original 8r cubed minus 64r squared plus r minus 8 back. Try number 7 and number 9 and check your answers in the locker, and please bring your questions to our Zoom. So these are quadratics that very specifically have a leading coefficient that is greater than 1. So my a value is a number other than 1. You can look at it here and see it's 2, here it's 5, here it's 3, here it's 6, and here it's 5. And in these problems, there's no GCF. I am not going to be able to factor out that number to get an a that's 1. So we need a method to factor these. There's actually multiple methods. There's the box method, there's slide and divide, guess and check, which is one of the ways that I grew up doing it. But one method that works that your math 3 teacher would like you to know would be factor by grouping. I'm going to change, I'm going to change to a 4-term polynomial. So all of these problems right here have 3 terms. They're all trinomials. And use factor by grouping. So how do we do this? We're going to use our diamond method. So let's take a look at number 11. I'm going to create my diamond, and if you remember from the front side, A times C goes at the top and B goes at the bottom. The number I put at the top is what my side numbers multiply to, and the number I put at the bottom is what my side numbers add to. So remember it's ax squared plus bx plus c. So my a times c would be 2 times negative 9 or negative 18. And then my b is 3. So now what I'm looking for is 2 numbers that multiply to negative 18 while adding to 3. Maybe you thought of negative 3 and positive 6. That's awesome. They're the correct answer. However, that can be a difficult step for some students. What I recommend is you can make a list of all the factors of 18. Start at 1, 1 times 18, go to 2, 2 times 9, go to 3, 3 times 6, then 4. If you do 18 divided by 4 on your calculator, you'll see you get a decimal, so it doesn't work. You could try a 5, it doesn't work. You could try a 6, and I'm back to 6 and 3. As soon as your factors repeat themselves, you're done. Now look at your choices. Which one of these choices can help me get the 3 on the bottom of my diamond? Well, 6 minus 3 is 3, so maybe that can help me. So then that's how I figure out I want a 3 and 6. And then I generally have to play with the sign to figure out, is my larger number the negative? Is my smaller number the negative? Are they both negative? It really depends on the problem. So let me show you. Do not write these in the parentheses. So everything I'm going to do here, I'm going to erase in just a moment. So please don't write this. Do not, like we did on the front side, write these in the parentheses. That is an incorrect answer. If I could take just a moment and FOIL this out, you would get an x squared. Your inner terms would give you a negative 3x. Your outer terms would give you a positive 6x. And negative 3 times 6 is negative 18. You actually would get x squared plus, that had an x, 3x minus 18. That is not what number 11 had for the trinomial. So you got to be really careful. When your a is not 1, you cannot write your side numbers in the parentheses. That's why we're going to change it to factor by grouping. So I'm going to write my 2x squared like normal, and I'm going to write my negative 9. Now the 3x I'm not going to write. Instead, I'm going to go get the numbers in the side of my diamond, and I'm going to write them instead. So I'm going to write negative 3x plus 6x. Negative 3x plus 6x does indeed equal 3x. I'm just, instead of writing positive 3x, I'm writing negative 3x plus 6x in its place. And I haven't changed anything because they're equal to each other. They're red, what I have in red. It doesn't really matter whether you write the negative 3 first or the negative 3x first or the 6x first. In the end, although our work looks different, in the end we get the same answer. So let's use our steps from the front side. Underline the first 2, underline the last 2. Let's factor in x from the first 2. I get x on the outside, and then I have 2x remaining when I divide 2x squared by x. I have minus 3 remaining when I divide 3x by x. Now let's take a look at the 6x minus 9. They both have a 3 in common. So make sure you have a plus sign there. That's really important. So now I'm going to factor out a 3 from both, divide both by 3, and I get 2x minus 3. Notice my parentheses match. Remember from the front side, they should match. And so I get x plus 3 times 2x minus 3. And now I'm done. And if I box or FOIL that, I really would get my original problem. Let's take a quick look at number 12. Let's write our AC at the top, and that's 5 times 12, or 60. Let's write our B at the bottom. That's 19, and that's my B. So this is where, if I list the factors of 60, it will help me realize that what I want to use here is 4 and 15. So 60 is 1 times 60, 2 times 30, 3 times 20, 4. When I do 60 divided by 4, I get 16. I get 15. 5 times 12. But let me go back. My bottom number is a 19. And I just noticed that 4 and 15, when I add them, equal 19. So I can stop listing my factors because I found the two I want. 4 times 15 is 60, and 4 plus 15 is 19. So I'm going to rewrite my 5n squared. I'm going to rewrite my plus 12. And now let me get a different color. I am not going to write 19n. Instead, I'm going to write plus 4n and plus 15n. Don't forget your n's. The 4n and the 15n need to add to 19n. Okay, so now I'm going to group my first two, and I'm going to group my last two. My first two have only an n in common, and 5n squared divided by n is 5n, and 4n divided by n is 4. 15n and 12 have a 3 in common. Make sure you have your plus sign in front of your 3. 15n divided by 3 is 5n. 12 divided by 3 is 4. Notice that my two parentheses match. They're supposed to. So let's pull out the matching parenthesis, 5n plus 4. And in the first half, when I divide that out, when I factor out my 5n plus 4, I have the single n left. And in the second half, my second term, when I factor it out, I have a 3 left. And this would be my final answer. You can try numbers 13, 14, and 15 and check your answers in the locker and bring your questions to Zoom. So the last factoring I want to review with you is the difference of two squares. I sometimes call this DOTS for short. DOTS, difference of two squares. D-O-T-S. So difference of two squares is simply a pattern. So if I happen to see that I have only two terms, notice each one of these have only two terms, and they're both perfect squares, then I can factor them into plus and minus their square roots. So what you need to do is you need to look at the first term and you need to figure out what the square root of it is. The square root of x squared would be x. So since that was the first number, I put that first in my two parentheses. Then you look at the second number. You ignore the minus sign. The minus sign is not important at this point. I'm only looking at the 25. The square root of 25 is 5, and so that's the number that goes back behind. And that's my problem factored. That's how I factor the difference of two squares. Let's try that again with number 17. So 25 and 121 are perfect squares. You got to check first. Just because there's two terms does not mean it's dots, does not mean it's difference of two squares. So this is a perfect square, 121 is a perfect square, and this is the difference of two perfect squares. So I know it factors into plus minus their square roots. So I look at the first term and I think of the square root of 25x squared. That's 5x. So I put a 5x in both sets of parentheses as my first term. Then I take the square root of 121. I ignore the minus. I'm not concerned with the minus at this point. I've already used it when I figured out this was the difference of two squares, so I'm not looking at it anymore. The square root of 121 is 11, and I put that second. If you're worried you didn't factor this correctly, then you could simply check it by multiplying your two binomials together. 5x plus 11 and 5x minus 11. 5x times 5x is 25x squared. Be careful. 5x times 11 is 55x. Negative 11 times 5x is negative 55x. And 11 times negative 11 is negative 121. So what always happens with difference of two squares, this positive 55x and this negative 55x cancels. That's what the plus minus does in my parentheses. And I get just 25x squared minus 121. So we'll look at this bottom part when I see you in Zoom. Go ahead and finish the problems we didn't do, check your answers, and I will answer questions in Zoom. Thank you.